Okay, IB App students, I am continuing my work on this circle problem from the previous page, and it started over here, and we calculated that the area of the lampshade was given by this equation right here. So now to continue on, I copied this picture, but then I did copy over the fact that this inner arc length is 1 meter right here to show that the smaller sector theta is equal to 180 over pi r. So I started with my arc length formula. Oops, that is not focusing. Started with my arc length formula. Try. There we go. Nope. And I substituted 1 for the arc length, which is over here. And then I combined these two. And now what I need to do is solve for theta. So first thing I'm going to notice is that 200 over 360 is equal to 1 over 180. So I'm just going to simplify that fraction. I get pi r theta over 180. Now to get theta by itself, I need to undo division by 180 by multiplying by 180, and undo multiplication by pi r by dividing by pi r. I'll do that on this side as well. So that cancels out my pi and my r and my 180, so theta's by itself. And this times 1 is going to be the same thing, 180 over pi r. So now I have that theta is equal to this. Okay, so to find r and theta, we're going to combine the expression from part A and part B. So this came from part A, but I know now that theta is 180 over pi r, so I can substitute this for theta right here. So I'm going to do 0.28 times, instead of theta, 180 over pi r over 360, and then that's times pi, and then 2r plus 0.28. So now my expression has only r as a variable and not r and theta. So I can simplify it a little bit here. I'm dividing by pi and multiplying by pi, so those can cancel. And I can multiply 0.28 times 180. Let's see. So I get 0.28 times 180, and it's 50.4, still over r. And this here, 2r plus 0.28, and then all over 360. And then I can distribute this. So when I multiply these, the r's cancel out, and I get 100.8 plus, and then when I multiply this, the r ends up in the denominator, so 14.112 over r, all over 360. And this is the expression for the area of the shade. And so now I can set this equal to the area of the shade from the other side, which was 0.32 square meters. Okay, so distributing the division here, when I divide these two, I get 0.28 plus this fraction divided by 360. And now subtract the 0.28 from both sides. and then multiply both sides by 360, and I should get about 14.4. All right, so I can multiply both sides by r, divide both sides by 14.4, and I'm going to get r is equal to 14.112 over 14.4, which is about 0.98. So I have a value for r. That was one of the things I was trying to find. And now I can substitute that back into this formula to find the value for theta. And you should get about 58.5 degrees. All right, so now once you know the value of little r and you know the value of theta, you can use that to find other values in the circle. So we're going to find the value of the longer arc. So the arc length is equal to, we have 58.5 degrees out of 360 times your circumference formula, 2 pi, and the longer arc is here, so we know that the short radius is 0.98, and then this piece here was 0.28, so we will add those 0.98 plus 0.28. All right, and when you calculate that, you will get that it is about 1.29 meters. Okay, so now we're going to look at another way to measure angles, which is in radians. And here you'll see measurements of 1 radian, 2 radians, 3 radians, but normally we measure radians in terms of how many pi radians there are. But remember, pi is just a number, 3.14. So the radius here is r, and if I take that same r and I spread it around here on the arc lengths, a semicircle, which is 180 degrees, is a little bit more than 3 r's, so 3 radians. And the exact amount, the semicircle, 180 degrees, is pi radians. And so when we measure angles in radians, often, almost all the time, you have pi in your answer. One interesting thing about radians is that when you write degrees, you have to write the degree there. But for radians, you usually don't put radians or anything after the angle. It's just assumed to be radians if it doesn't have a degree. All right, so converting from degrees to radians, if you have degrees, then you can divide by the degrees to cancel out and multiply by the pi radians. Or the other way around, if you have the radians, you can divide by pi radians to cancel them out and end up with degrees on top. So that's one thing you can do. Another thing that works really well, and this is what I'll use more often, is just set up equivalent ratios. So you know you have your degrees on the top, so you put your degrees on the top. You have your radians on the bottom, so you put your radians on the bottom. And that's what I'm going to use to solve these here. So I have 180 degrees over pi radians is equal to 50 degrees over x radians. Okay, so if I multiply, I will get 180x is equal to 50 pi, and then divide by 180, I get 50 pi over 180, which simplifies to 5 pi over 18, and that would be my radian measure. To convert to degrees, I'm going to do the same setup. 180 degrees over pi radians, x degrees over pi over 6. that would give me pi x, and that would give me 180 divided by 6 is 30 pi. And the pi's will cancel, and I just get x is equal to 30 degrees. All right, we're going to do an arc length problem with a radian measurement. So the fraction was over 360 degrees when it was degrees. In a full circle, you have 2 pi radians. Remember, a half circle was pi radian, so a full circle is 2 pi radians. So your fraction is going to be 7 pi over 4 over 2 pi radians. And then you're going to multiply that by your circumference formula, which is 2 pi r. Now, we're trying to find the length of an arc, so we don't need pi in our answer, only need pi in our answer when we're converting to radians. So you can substitute this into your calculator, and you're going to get that it rounds to 3 sig figs, 110 centimeters. Okay, the next one is asking you to do the same problem but with degrees. So just a reminder, 315 degrees out of 360 times 2 pi times 20. And when you do that, you're going to get the same exact answer, which 3 sig figs is 110 centimeters. And that does lead you to believe that perhaps 7 pi over 4 is the same as 315 degrees. All right, finally, we're going to talk about our unit circle. And on the unit circle, we have very specific measurements. We're going to talk more about the unit circle next time we have a lesson. But for today, we're just going to talk about the angle measurements. So the unit circle starts on the positive x-axis right here at 0 degrees. And it goes counterclockwise. So this is 0 degrees, which you know that this would be 90 degrees, 180, and 270. Down there. Maybe I can zoom out a little bit, but I'm afraid to mess with my camera. All right. Here we are halfway to 90 degrees. That would make this 45 degrees. This is halfway between 90 and 180, and that makes it 135 degrees. Okay, halfway between 180 and 270 is 225 degrees. And then halfway between 270 and 360. So notice this is both 0 degrees, and when you come back around again, it's 360. So halfway between those is 315 degrees. All right, as you are looking at these, I want you to notice that if we ignore this middle one, that these are all equal pieces of the arc. And so we have 90 degrees, so this cuts them into 30s. So this would be 30 degrees and 60 degrees. There's 90, and we're going to add 30 again, 120, 150, 180. Add 30 again, 210, 240, and 270. Add 30 again, 300, and 330. So the degree measurements are 30, 45, 60, and then finally 90. And then continuing in a pattern. For the radians, of course, you could just convert each of these angles individually to radians using the method that we used on the previous page. But you can also try to learn the patterns for these as well. So we know 0 degrees is 0 radians, and we know 180 degrees is pi radians. That means 0 degrees could also be called 2 pi radians when we get back around to it. All right, so 180 degrees is pi radians. Well, this is going to be half of that. That's pi over 2 radians. And that means this is going to be a fourth of that, so that would be pi over 4. So we had pi, we cut it in half, we got pi over 2, we cut that in half, we got pi over 4. So every time we go 45 degrees, we go pi over 4 radians. This is 2 pi over 4, which is pi over 2. And then this one is 3 pi over 4. 4 pi over 4 is just pi. And this one is 5 pi over 4. 6 pi over 4 simplifies to 3 pi over 2. And then 7 pi over 4. And then 8 pi over 4 is 2 pi. All right, over here. This one is a third of 90 degrees, so it's 1/3 of pi over 2, which makes it pi over 6. So, oops, you didn't see that at all. 1/3 of pi over 2 is pi over 6. So every time we go 30 degrees, we go pi over 6 radians. This one is pi over 6. This is 2 pi over 6, which is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. 5 pi over 6. 6 pi over 6, 7 pi over 6. 8 pi over 6 simplifies to 4 pi over 3. 9 pi over 6. 10 pi over 6 is 5 pi over 3. And then finally 11 pi over 6. So, looking at your first quadrant, we have pi over 6, pi over 4, pi over 3, pi over 2, and that's what we put here.